mug, and I'm going to do this a little bit different today. I have something I want to show you guys, and you know how you hear on the news how they say we're going to see robots and androids by 22nd century, 21 something, or 2050 or 2075. I think we're going to start seeing full-fledged autonomous robots walking the streets. And I'm not saying that to scare anybody, but it is alarming. It is. I want to show you guys just a small clip, and I'll give you my thoughts on it. We're going to do a review of this video. I think we're going to see full-fledged androids in 10 years. 10 years. Not 50, not 100. 10. It's incredible. What we're about to see here is a review of a video that I saw talking about soft robotics. And this company is able to create, okay, when they talk about soft robotics, it's robotics like parts that are soft and flexible and, mushy, like our muscles are, we're robots. We have hydraulics, we have circulatory systems. Now they're able to start making robots like this. We're going to play this video and I'm going to stop it through as we go. I'm going to take off my camera so that you don't have to look at my mug the whole way through. And let's get started on the video.
There has been a handful of truly wild advancements in the robotics field lately. These advancements don't involve the typical rigid robots made out of hard materials, doing backflips, or making pizzas. These advancements are a bit stranger. They are inspired by human flesh, and inspired by how humans move. These advancements may lead to androids similar to the ones found in HBO's Westworld. Will we ever see androids anywhere near the kind seen in Westworld in our lifetimes? It's really hard to imagine at this point, but these 4 incredible advances are steps in the right direction. Alright, the first advancement takes us to the University of Colorado Boulder, where researchers are pushing the boundaries of soft robotics. Soft robotics is a subfield of robotics that is built on how living organisms move and interact with their environment and deal with compliant materials versus rigid materials.
Okay, so what you're seeing here, and I had to look at it a couple of times. This is a material, plastified material filled with vegetable oil. And as they apply current up here on the top of the screen, as they apply voltage through this material, the material reacts to the circuitry, either contracts or relaxes. And the oil inside obviously is a buffer so that the material, the layers don't touch together. And it's lifting a weight, this weight down here. Check it out. We'll keep going at this.
The researchers at Boulder developed a hydraulically amplified self-healing electrostatic actuator, or Hazel actuator for short. The actuators are made out of elastic pouches connected to electrodes and filled with vegetable oil. The oil is an electrically insulating liquid, and when electricity is applied, the oil is displaced, making the artificial muscle contract. And this can happen in milliseconds. And changing the shape and configuration of pouches will produce different movements. Assistant Professor and Fellow of Material Science and Engineering Program Christoph Kepling.
I'll back it up so you guys can hear who Christoph Kepling is. But this arm right here, this is just a plastic bottle, obviously made of plexiglass, with let's call it a synthetic muscle here. And you saw how it was able to lift slowly or fast, or cause a burst of motion. This is incredible, because robots right now today are based on hydraulics. You need hydraulic cylinders, hydraulic hoses, pumps, motors. Essentially, when I used to do pool installation, we would use what we call a bobcat. It's a little tractor with a bucket on the front. And it was neat, because as you drive it, your arms and your feet are converted to these arms in this bucket that would lift up and lower down, do whatever you wanted to do. It was pretty impressive when you realize that my hands were controlling tons of weight. But now, instead of having these huge arms made of steel and hydraulic cylinders and hydraulic hoses and a motor behind you wailing, because you could hear the hydraulic pumps, this is being done with a few volts passing through a material like this one here that is essentially, I mean, you got to think of the force here. right here where my mouse is a pivot point, and this is your anchor point for the muscle. This would be your elbow, for example, right here. This would be the arm, and here's your hand. This length is multiplied. Every inch is multiplied by the weight of the item on the end, is multiplied by the number of inches in force in order to lift and move this, ball up and down over here. It's laws of physics here. But it's incredible. It's like, wow, yeah, that's what I mean by it. If they've already invented this. Now we're going to go on, and I'll tell you why I think we're going to see androids autonomous in the streets soon.
Program Christoph Keplinger says Hazel actuators synergize the strength of soft fluidic and soft electrostatic actuators, and thus combine versatility and performance like no other artificial muscle before. Just like biological muscles, Hazel actuators can produce the adaptability of an octopus arm, the speed of a hummingbird, and the strength of an elephant. End quote. And what might be the most incredible part of this advancement is that the devices are made out of low-cost material and can be made for just 10 cents. The researchers are continuing to improve the technology.
10 cents per actuator. 10 cents. Not $10,000 per actuator, not $1 million like we hear some technology when it's coming out. It's like, this is going to cost millions of dollars, but as more applications are developed and people order more of this product, the cost will go down. No. This is like real soon. 10 cents. So if you need 1,000 actuators in a body in order to make a body move, an actuator meaning a muscle. So in your arm, you got multiple muscles moving. Some are pulling, some are pushing at the same time, but each one is an actuator. So if you just say you need 1,000, you're looking at, and I'm not kidding you here, you're looking at $100 in materials. 100. Wow.
The actuators currently take a lot of power, but they are working on devices that will operate on 1/5 of the power. And they have secured patents for the technology and currently exploring commercial opportunities. Who wants to see Boston Dynamics or Hanson Robotics license this tech? I sure do. Alright, the next advancement makes me think of the T-1000 or Wolverine. Researchers at a Belgian university have developed technology that may one day allow robots to have self-healing skin. The fingers you see are made out of squishy polymers with lots of strands. The strands are microscopic chains that are held together, and the fascinating part is that the bonds break when you heat the material, and as it cools, the chains bond back together. The team of researchers are now working on a way to load the material with sensors so that eventually, when the technology is applied to a robot, it can sense when it has an injury and then heal itself accordingly. Currently, it takes about 40 minutes to heal a wound at 80 degrees centigrade. But
okay, so what you saw there, we're back here where we see the healing process here. This is essentially, I'll just give me 1 second. I just want to get back to where we were. This where you've seen the healing process. This is like Hollywood here, where it's sped up. But this is 40 minutes at 80 degrees centigrade or Celsius. So a small cut. That was a small incision that was made. But yeah, could you imagine? The robot gets cut, God forbid, we're trying to stop it. We have to shoot it. We shoot it. Its skin is pierced. Either it continues after you, but while doing so, it applies heat to its skin, and its skin heals. Like you just saw on the screen. It's like the skin heals. I mean, while it's still coming at you. Now, okay, let's assume that robots don't come after us. Now, I'm going to stop the video here because the rest of the show doesn't really apply to what I was saying, what I want to say, but if we can make mushy robots, soft robotics like this, where there's muscles that are controlled by electricity, relatively small amounts of electricity compared to what it takes for hydraulics, I I know there's another company that's invented a skin that allows the robots to feel that, like a sensor grid, if you want. It knows if it's touching or if it's being burned. It can tell you what regions are hotter or colder. There's another type of skin from another company that made it so they can actually feel. They can determine whether it's cold, hot, but not just that, but metal, wood, ceramic, plastic. So the skin technology is there. The skin healing properties are already here. Muscles are already here. We have the electronics. I mean, some of these computers are a size of they're called Raspberry Pis. Go look it up on Google. Type in Raspberry Pi, and they're little tiny computer motherboards, fully functional computer systems. I've seen some people use them for their desktop computers. So you put 5 or 6 of those, 10 of those into a body with a couple of batteries, and you've got it made. They have made what was I going to say? They have made batteries that are mushy, as opposed to hard lithium-ion batteries. There are actual batteries which are flexible and you can bend around your arm and put out a lot of voltage, just like an electric eel. So now, why do I say in 10 years we're going to see these things walking the streets? Okay, maybe walking the streets is a little far-fetched. Maybe we'll start space station, but we're going to start seeing them on a more and more regular basis. Not just these big, bulky, plastic, metal robots like we see from Japan, but we're going to start seeing these as helpers. And why I say that is Google's cloud learning or advanced learning technology, AI technology. There is emotional learning technology. There are emotional AIs, empathetic AI, artificial intelligence. There is quick learning intelligence. If these companies got together, one company with the skin, one company with a robot skeleton form, one with a battery technology, one with the let's say computers and architecture, another with like I said, with the AIs, put all that together. And after a couple of years, especially if somebody were to come up with a challenge, a prize, if someone, for example, like they did with SpaceX, there was $1 million prize for the first group that can make a vehicle that can travel on Mars. One group won the $1 million prize, and that device went to Mars and traveled on Mars. If somebody were to come up with a contest saying, "Hey, make the first soft robotic robot fully functional where it could feel, heal, work, move about autonomously, learn, adapt," you win, let's say, $100 million. Every company, every technology company in the world is going to jump on this and say, "Yeah, we're going to do it." So, and then what's the next step after the "yeah, we do it"? It's "yeah, let's sell it." So those are my thoughts. I saw that last night. I thought it was horrendous. Like, wow. This is stuff that I only dreamt of as a kid. When I was like 7 or 8 years old at bedtime trying to fall asleep, and I would think about, robots and spaceships and stuff like that, so it's coming true in my lifetime. We're going to be on Mars way sooner than we think. We're going to be living on the moon in my lifetime. I'm still 43. In my lifetime, it's going to happen. It's going to happen. I don't think the society is ready for it. I don't think so. It's going to be a shock to a lot of us. Tomorrow's Nelson's Thoughts, I'm going to talk about the latest Falcon Heavy rocket launch from with Elon Musk's Falcon Heavy rocket that was launched from NASA, Cape Canaveral. It launched, it deployed, and it returned back to Earth successfully. When I mean return back to Earth, the rockets and the rocket boosters, everything came back into the atmosphere and controlled landed perfectly so that it can be reused again in a few hours. And one person said, why would we have planes if you got in a plane, you flew to your destination, but you had to destroy the plane at your destination? It would be useless. They reuse planes. Now they're starting to reuse rockets. So tomorrow I'm going to talk about that. I'm going to show the footage of the space launch of the Falcon Heavy rocket and the return landing of the Falcon Heavy rocket, it is incredible. I'll do the commentary on this. It is incredible watching this technology. It's, again, these are companies that are saying that they want to move forward. They got a reason to do this, and it's bigger than you and I would know. So that's my thoughts for today. Hope you guys liked it. Maybe this will be Nelson's thoughts going forward. No idea. Well, I'm going to leave you guys with that. Cheers, and I'm out of here.